Download this code from codegive.com, link in the description below. OK, let's dive deep into different techniques for iterating over two lists in Python, complete with detailed explanations and code examples. We'll cover several approaches, discussing their use cases, advantages, and potential drawbacks. Understanding the need for iterating over two lists. Before we get into the techniques, let's clarify why you might want to iterate over two lists simultaneously. Here are common scenarios. Element-wise operations. You want to perform calculations or comparisons between corresponding elements in two lists. Parallel processing. You have related data in two lists, and you need to process them together to achieve a specific outcome. Data alignment. You want to create a combined data structure, example a dictionary, based on the elements in two lists. Validation. You need to verify that the contents of two lists match or conform to certain criteria. Technique 1, Basic for loop with indexing. This is the most fundamental approach. You use a for loop to iterate over a range of indices and then access the corresponding elements in both lists using those indices. Explanation. 1. Length check. We start by verifying that the two lists have the same length. This is crucial because if the lists have different lengths, you'll encounter an index error when trying to access an element beyond the bounds of the shorter list. 2. Range, len, list 1, this creates a sequence of numbers from 0 up to, but not including, the length of list 1. These numbers serve as indices. 3. List 1I and list 2I inside the loop, we use the index I to access the element at that position in both lists. 4. Processing. You can then perform whatever operation you need to do with element 1 and element 2. In our example we use ord, to get integer representation of a char. 5. Alternative example. We can also store the result of operations in list 3 to keep track of information. Advantages. Simple and easy to understand, especially for beginners. Gives you direct access to the index if you need it for other purposes. Disadvantages. Can be verbose, especially if the lists are long. Requires manual length checking. Less Pythonic than other approaches, i.e., doesn't fully leverage Python's features. Technique 2, Zip, function. The zip function is a built-in Python function specifically designed for iterating over multiple iterables, like lists, in parallel. It creates an iterator of tuples, where each tuple contains the corresponding elements from the input iterables. Explanation. 1. Zip, list 1, list 2, this creates an iterator that yields tuples like a, 1, b, 2, c, 3, etc. 2. For element 1, element 2 in, the for loop unpacks each tuple into the variables element 1 and element 2, making it easy to access the corresponding elements. 3. Different lengths. Zip stops iterating when the shortest iterable is exhausted. Elements in the longer iterable are ignored. Advantages. Concise and readable code. Automatically handles parallel iteration. Handles lists of different lengths, by truncating to the shortest. Very Pythonic. Disadvantages. If you need the index, you'll need to use enumerate, in combination with zip, see next technique. Truncation behavior might not always be desired. If you require the lists to be the same length, you still need a separate length check. Technique 3, Zip, with enumerate, for index and values. Sometimes you need both the index and the values from the lists. You can combine zip with enumerate to achieve this. Explanation asterisk. 1 zip, list 1, list 2, asterisk as before, this creates the iterator of tuples. 2 enumerate, zip, list 1, list 2, asterisk enumerate, takes an iterable, in this case, the zip object, and returns an iterator that yields tuples of the form, index, element, where index is the position of the element in the iterable. So, the first element yielded will be 0, a, 1, the second will be 1, b, 2, and so on. 3 for index, element 1, element 2, in, asterisk the for loop unpacks each tuple returned by enumerate, into index and another tuple, element 1, element 2. Advantages asterisk. Asterisk provides both the index and the values in a clean way. Asterisk still relatively concise and readable. Disadvantages asterisk. Asterisk slightly more complex to understand than the basic zip approach. Technique 4, itertools.zip_longest, for handling unequal length lists. If you need to iterate over 2 lists of different lengths and you want to handle the missing elements gracefully, itertools.zip_longest, or izip_longest, in Python 2, is your friend. It pads the shorter list with a fill value, default is none, so that the iteration continues until the longest list is exhausted. Explanation asterisk. 1 itertools.zip_longest, list 1, list 2, fill value equals n/a, asterisk this creates an iterator that yields tuples. When one list is exhausted, it uses the fill value, here, n/a, to pad the missing elements. If you don't specify fill value, it defaults to none. 2 The for loop then processes the tuples as usual. Advantages asterisk. Asterisk handles unequal length lists without truncating or raising errors. Asterisk provides a way to control the value used for padding. Disadvantages asterisk. Asterisk requires importing the itertools module. Asterisk you need to be mindful of the fill value and how it might affect your calculations or comparisons. Technique 5, list comprehensions. List comprehensions offer a concise way to create new lists by applying an expression to each element of an existing list, or lists. They can be used effectively when iterating over 2 lists to generate a new list based on their corresponding elements. Explanation asterisk. 1x asterisk y for x, y in zip, list 1, list 2, asterisk asterisk this creates a new list where each element is the result of multiplying the corresponding elements from list 1 and list 2 obtained using zip. 2xy for x, y in zip, list 1, list 2, asterisk a list comprehension can also incorporate conditions to decide which elements to include or how to transform them. 3x plus y if x is not none and y is not none else, x or 0, plus, y or 0, for x, y in itertools.zip_longest, list 1, list 2, asterisk the itertools.zip_longest, function is used to handle lists of different lengths. The expression ensures that non-values are treated as 0 for the purpose of summation. Advantages asterisk. Asterisk concise and expressive. Asterisk can be very efficient for creating new lists based on existing ones. Asterisk highly readable when the logic is straightforward. Disadvantages asterisk. Asterisk can become less readable for very complex logic. Asterisk not suitable if you need to perform side effects within the loop, example modifying elements in place. Choosing the right technique. The best technique depends on your specific needs. Asterisk simple element-wise operations on lists of the same length asterisk zip, is usually the best choice. Asterisk need the index asterisk use enumerate, zip. Asterisk lists of different lengths, and you want to ignore extra elements in the longer list *zip, will truncate automatically. Lists of different lengths, and you want to handle missing elements gracefully *, use itertools.zip_longest. Creating a new list based on element-wise processing * use a list comprehension with zip, or itertools.zip_longest. For complete control and flexibility, but more verbose code, the basic for loop with indexing. Important considerations readability choose the approach that makes your code the most clear and understandable. Performance for very large lists, consider profiling your code to identify any performance bottlenecks. In most cases, the differences in performance between these techniques will be negligible. Error handling always consider how to handle potential errors, such as lists of different lengths or invalid data. By understanding these different techniques and their trade-offs, you'll be well equipped to iterate over two lists effectively in your Python programs. Remember to prioritize readability and choose the method that best suits your specific task.